For sure there would be on-site measurements, would be cycling, and there would be aerodynamic drag.
For Technology 2020, I'm touring the country with the technology demo bus looking for interesting innovations. Our final stop for today is Delft, where we will visit 3 projects that have to do with aerodynamics. Meet Alexander. So Alexander, we're here in Delft in a wind tunnel, but to be honest, I expected something a little bit different when I read about a mobile wind tunnel that you developed.
Yeah, so we are here now at the Open Jet facility of TU Delft. And in this kind of wind tunnels, normal research is done into cycling. So we put a cyclist here still on a force balance and we blow the air around it. With our mobile wind tunnel, you do the opposite. You have the air standing still and you let the cyclist move through it. So that's actually the biggest difference. So we use a technique called particle image velocimetry, where we have bubbles and then we track the movement of those bubbles. And from that we can extract the velocity field, and from the velocity field we get all the forces that we want. The challenge is that you need bubbles that reflect enough light, because we illuminate them with a laser, so that we can track the movement of them. But they also need to follow the air. And if you want them to follow the air, you want the particles as small as possible. But then they don't reflect enough light anymore. So we needed big particles that reflect a lot of air that were as light as air. And since we have now the soap bubbles filled with helium, in total the bubble is exactly the density of air and it tracks exactly the movement of the air.
And so are you able to do this analysis on site actually, or do you just record the images on site and then you process the data back at the university?
We do a bit of both. What we basically do during the measurements, we record a whole bunch of data and then we pre-process a little bit of the data to check if it all went okay. And from that we can already get a general idea of the drag of the cyclist. But the detailed analysis we for now still do here in the lab. The future plan is to really make it a direct system so that you get feedback to the cyclist the moment he passes through. And we now did last year the first real application with it. We were working together with Team Sunweb to optimize their time trial, team time trial positions of different cyclists. That was actually the real first application.
Okay, and when working with Team Sunweb, can you say anything about the results that you achieved?
I think if I would say any of the results, they would not be too happy about it.
But was it worth their while, so to say?
Yeah. They really got something out of it, especially for the team time trial last Tour of France. We delivered some results to them, and based on those results, they already changed some of the setup of their team time trial. Okay. So that was really cool to see.
Yeah, that's nice to see your results being applied in practice then, I guess.
Exactly, yeah.
So in a few years, all of us can try this trackside.
Hopefully, yeah.
Okay, so final question. So if I ask you to summarize your project in 3 keywords or 3 key concepts, what would those be?
For sure there would be on-site measurements, would be cycling, and there would be aerodynamic drag.
So there you have it. Technology creates interesting connections. On to the next one.